Hi everyone, this is our first attempt at a review PowerPoint using Edpuzzle. So we're going to go over one of the last things that we covered in class, and that was Pythagorean theorem. So what is the Pythagorean theorem? Everyone should have said a squared plus b squared equals c squared. We've heard it so many times for so many years now. Hopefully that's ingrained in your memory. And C represents the hypotenuse, which is the slanted diagonal from the right angle in the triangle, and it's always your longest side. A and B represent the legs of the right triangle, and they form the right angle. Keep in mind that Pythagorean theorem only works for right triangles. So any other type of triangle you're dealing with, obtuse, acute, Pythagorean theorem is not applicable. Okay? So how is the Pythagorean theorem used to find missing sides of right triangles? That's what its purpose is. It's to help you find missing lengths, distances, using right triangles. So we've got two different scenarios that you have to choose from when solving. Either you're going to be solving for a missing leg, so one of the perpendicular sides, or the sides that intersect perpendicularly to form a right angle, or you're solving for a missing hypotenuse, slanted side. Regardless, your first step should be to go ahead and write out the theorem and then substitute your known numbers, your known or given information. And your next step, no matter what, is going to be to square those numbers that you already have. So exponent 2. This next step is where your procedure differs. If you're solving for a missing leg, then you're going to subtract next. And if you're solving for a missing hypotenuse, you're going to add those two numbers. Okay? And your last step is going to be to find the square root. So all these steps, whether it's solving for a missing leg or a hypotenuse, very, very similar. Only one difference, subtraction versus addition. So let's take a look at a couple of examples. Here's your first practice question with Pythagorean theorem. I'd like for you to determine the length of the missing side of the right triangle and round to the nearest hundredth. So you'll need a calculator. And we're trying to find a missing leg. So I'm going ahead and giving you that information. We're solving for a leg here. You should have got the result 14 and 1400ths feet. And here are the steps that you should have followed to find that answer. So here's my Pythagorean theorem. I know that one leg is 5 and the hypotenuse is 15. I square my numbers. And then, since I'm solving for a leg, I subtracted. And my final step was to take the square root. And notice that square roots and an exponent of 2 are inverse operations. So taking the square root of a squared leaves me with the variable a by itself. Okay, let's take another look at another example. And for this one, I've told you that you're solving for a missing hypotenuse C. Same instructions, determine the length of the missing side of the right triangle round to the nearest hundredth. Hopefully you were able to get the result 8 and 600ths feet. Here were the steps in between. So here's my Pythagorean theorem. And the information that I do have is that my two legs are 7 and 4. It doesn't matter which number goes in place of A versus B, since addition is commutative. You could have switched it around and 4 could come first and then 7. And I'm adding because I'm solving for a missing hypotenuse. And my last step was to take the square root of both sides. Okay. Pretty easy, hopefully. If not, don't worry. I've got some more practice coming up for you in a Google form after you finish this Edpuzzle. Let's go ahead and take a look at the most challenging type of problem you might see with Pythagorean theorem in Math 2. So I pulled this question from the state pacing guide and did my best to represent the picture that they had as artistically as possible in PowerPoint. So just imagine that this is a river and you've got two river banks here, and we're trying to figure out distances across the river from different points. Okay, so our ultimate objective here is to calculate the distance across the river from point C to point B, given that the triangle ABC, so this small triangle here, is similar to the large triangle EBD. And that's important information. Okay, so imagine this is your river and we're trying to find the distance between C and B. All right, and I'll go ahead and give you a couple of hints on how to get started here. So that piece of information about similarity is important. So we're going to label segment AB as the variable X. And the next thing you should do is set up a proportion comparing corresponding sides of the two triangles to solve for X. So if two triangles are similar, then they're related by a specific ratio. So I know the base of the small triangle is 40 and the base of the large triangle is 60. And they have some mathematical relationship, 40 and 60. And I can compare that to the relationship between the height of AB and the height of EB. They should maintain that same mathematical or numerical relationship that the two bases have. So give this problem a try. It should definitely take you at least a couple of minutes to solve it. It is a little bit challenging. Once you've figured out what AB is, what X is, then you can use the Pythagorean theorem to determine the length of segment CB. You should have got the final result 72 and 11/100 meters, which is not a nice number, but here's how you get it. So my first hint was to label this side AB as the variable X. All right. Then my next set of directions was to set up a proportion. So if we compare the small triangle to the large triangle, my ratio would be 40 to 60. The base of the small triangle is 40. The base of the large triangle is 60. Here's where it's a little bit tricky. My height of the small triangle is X, and the height of my large triangle is X plus 30. So when I'm solving proportions, if you'll remember way back a few weeks ago, I personally like to go ahead and simplify this fraction if I can. So I'm working with smaller numbers when I cross multiply. So when I cross multiply, I get 3x. And don't forget, you need to put parentheses around this term in the denominator, x plus 30, so that the 2 gets distributed. And you have 2x plus 60. Then you would subtract 2x from both sides of your equation to get the result x has a value of 60. So now that you know the height of your triangle, smaller triangle, is 60, you can use the Pythagorean theorem because you now have one leg and a second leg of a right triangle. So 60 squared plus 40 squared, we're substituting our known information, and we square our numbers, and we're adding them together because we're finding a missing hypotenuse. Then your last step is to take the square root of both sides, with your final result being the 72 and 11/100 meters. Okay. So that was your quick review of Pythagorean theorem. I've got a Google form on Google Classroom for you with a handful more practice questions on Pythagorean theorem. When you get back from spring break, be on the lookout for some review videos and assignments on simplifying radicals and special right triangles. See you soon. Bye.